What is going on, guys, and welcome back to another video. It has been quite a while since I've posted because school has been quite busy and also other things. So yeah, let's get back into it though. And today I'm gonna do something which I wanted to talk about for a long time, and that is actually the three functions which we can use in a triangle, or basically any angle. We can use these functions. So yeah, actually this is sine, cosine, and tangent. So how do you spell this? I'm just gonna write this. You say sine with an E, then you say cosine, and then you say tangent. Okay, so these are the three names, and the question is, how did this even, like, or where did this come from, you know? How did we figure out that these three functions even exist, and how can we apply them, of course? So let's have a look. Alright, so let's have a look at this. So I actually just drew a circle here, and all of these numbers is basically just ones. So the radius of the circle is 1. So let's just write that down. So we have r is equal to 1. And so this is basically where these three functions come from. And actually, what do we call this circle? We call it the unit circle. That's what it is actually. Why? Because the radius is 1, and the special thing about this circle is that the radius isn't 1 centimeter, 1 millimeter, 1 inch, 1 whatever, you know, length of measurement, but it's just 1. So there is not really anything specified there. So let's now have a look. If we draw some radius, any given radius, right? So let's just or any given angle with the sorry, I did not put down the axes. Alright, let's say, for example, we have this line right here, right? And we have alpha right there. So how are these three functions defined? Well, some of you guys might already know. Let me just take that away for you guys. That the sine of an angle is the opposite side to the longest side, right? The cosine and the tangent is equal to this was this all right. Oh, this is actually the opposite. Alright, so these are the three definitions how we define these functions. So we have OS as opposite side, and we have LS as longest side, and we have CS as closest side. So let's have a look at this. So what we actually must do to find, or to just define this, is we just draw a line straight down from where basically a radius or our angle intersects the circle. So at this point right there, and we have two different lengths now. We have the length right here, this one, and we have this length. Should have done it in a different color, which I will do. Alright, so we have two different lengths right here, and now one of you guys, or some of you guys, will already know which one of which is which. But yeah, so we have this triangle, right? And the longest side, which one of these is the longest side in the triangle? Well, we know that first of all, we also know that there's a right angle right here, right? Because this is just 90 degrees. All right. So which one of those is the longest side? Well, obviously this one, so always the radius. And now the question is, but I said previously that the radius is exactly equal to 1. What does that mean for us? For this given circle right here, the sine of any given angle is just the opposite side. You guys see that? So, what does that mean? We have the sine here, and we have the cosine here. And it's not just really saying you have the sine here, cosine there, but the length of this line is the sine. That's what comes out when you type this in. And the same goes with the cosine. The length of this line basically is the cosine. And so one more function that we did not define yet, well, what is the tangent? We said opposite side to the closest side. Well, okay, that's this one to this one. So, okay, what can we also say? Opposite side to close side, right? And we said in this case that LS is just equal to 1. So we can write this in this case as opposite side, and in this case as closed side, right? And so if tangent of any angle is just the opposite side divided by the closed side, then we can also say that the tangent of any angle is equal to the sine of any angle divided by the cosine of any angle. Does that make sense? So I basically just said, because this is 1 in this example, this is 1, and this is also 1. So we just get this, so CS divided by 1 is CS, and OS divided by 1 is OS. And so, because the definition of the tangent is OS divided by CS, we can just plug this in for this, and we can just plug this in for this, and this in for this, and so we get sine divided by cosine. Also a nice thing to know. All right, where is the tangent now? So let's have a look. So the tangent is actually when we draw a line that intersects this circle at exactly one point, which actually what the tangent describes. A tangent is defined in a way in which it only intersects the circle at one specific point. So that actually, the name says it itself. Okay, but now where's the tangent? This is just the line. We didn't calculate anything yet. So the tangent is actually when we extend this line right here. There we go. That's the tangent right there. You guys, where is the tangent still? Sorry about that. Got a little bit too fast there. The tangent is actually, let me use a different color there. Tangent. The tangent is this line. This length. From the intersection down to here. This is tan. Alright, and do you guys see why this is the tangent? That is a very important thing in math. Understand, and because if you don't understand something, how can you first explain, and how can you even apply it? Like, if you don't understand this, then there is no point in learning it. Guys, in everything that you learn, number one is to understand, and afterwards you can learn. You know what I mean? Like, I can do this off the top of my head because I really understood this, but that's the only reason that I can do this. If I were to memorize everything, I could not be talking about this as freely as I am now, really just understanding it. Okay, anyways, get back to the topic. So, what is the question? Why is this the tan? So, if we draw out this big triangle right here, here it is. We just drew out this big circle. You guys see that? All right. We said sine is here, cosine is here, tangent is right here. All right, you guys got that. All right, good. Why is this the tangent? Why is it defined opposite side divided by the cos? Well, so we can see here that we have an angle here, right? And we have, okay, let's just call this angle alpha again, right? So let's just call it that again. We also have an angle here, right? Which is let's just call it beta. But because you can see that the proportions of this triangle and this triangle are the same, of the big one, of the big triangle and the small triangle, the proportions are the same. So basically the sine and cosine values are the same. Yes, they are, exactly. So in this case, we can also put down beta right here, right? Exactly, good. And now the question is, why is the tangent the opposite side divided by the close side? So let's have a look at it. So tangent, as we said, is sine divided by cosine. Okay, now how do we figure this out? Why is it like this? All right, so let's just actually do some assumptions here and some practical math. So let's say the angle is 0 degrees. Well, let's just define alpha as 0 in this case. Okay. What is if alpha is equal to 0? If this angle is 0, what does that mean? This straight, the radius which we are working with, is going to be exactly on top of the x-axis. What does that mean? Well, as you guys can see, the sinus will shrink down to 0 and the cosine will actually expand to 1 because it will be exactly as big as the radius. So if we just plug this in for the tangent, so we just write tangent of 0 is equal to sine, which is 0, over 1, which is the same as 0. So the tangent of 0 is 0. Is that right? That is actually correct, yes. Let's have a look at another example. Let's say tan of 45 is what? So we know that if a triangle has 45 degrees here, it must also have 45 degrees in this angle, right? We know that, we learned that. Why? Because the sum of all angles, sum of all angles in a triangle must be equal to 180 degrees. Good. So we have 90 plus 45 plus 45, so that's just simple math right there. Anyways, if the tangent is 45 degrees, what does that tell us? Well, that tells us we don't even need to know the sine and cosine values, but we know that sine and cosine must actually be the same, right? Because these two angles are the same, which means not only these two angles are the same, but sine and cosine must equal each other. So what can we say? If sine and cosine are the same, then we just have x over x, right? And which is just 1, right? Can you guys follow me here? I think that's pretty well explained. So again, if we have an angle of 45 degrees, I'm using simple degrees here, or simple angles here because of the calculation. Because to not use a calculator, having to use a calculator right now to show you guys these examples. So tangent of 45 degrees, these two are the same, which means the same over the same is equal to 1 because you can just cross this out, right? All right. Let's have a look at another example. For example, let's look at tangent of 90 degrees. And here's actually a thing that you guys need to remember. The tangent of 90 degrees, what does that mean? The question is, at which point does this straight intersect the y-axis? Is there an intersection? And the answer is no. Because these are parallel lines. These two lines are parallel. The y-axis and this line are parallel, which means they will never intersect. At least not in two-dimensional space. In three-dimensional space, they will intersect. Anyways, so they are parallel lines, and so yeah, they won't intersect. So actually, the tangent of 90 degrees is undefined. No, just write that. because it's not infinity because they won't meet. You know what I mean? It's not infinity because no matter how high you go, those lines will still be exactly one apart, and so they will never meet. So that's why tangent of 90 degrees is undefined. Oh, well, what have we established now? We now know what the cosine and sine are, and we know what the tangent are, but the question is, can they be negative? Which values can they take? And even, let's maybe compute some of these values. So let's see. Let's split the circle into 4 equally large pieces. So let's just split it into 4. Let's say this top right piece is piece 1, piece 2, piece 3, and piece 4. Let me make that a little bit bigger for you guys. So we have 1, 2, 3, and 4. We go against the clock. Why? Because that is the positive direction in mathematics, right? Remember that, guys. Alright, so I now created a table right here. I hope you guys can see that. Let's have a look at the values, positive or negative. Okay, so we have the first quarter, which goes from the y-axis to the which goes from the positive x-axis to the positive y-axis. So basically this quarter right here. Does the sign go in the positive x direction? Yes, it does. Which means the sign in the positive y direction, of course. Which means it's positive, plus. All right. Does the cosine go in the positive direction of x? Yes, it does. Which means it's also positive. Question: does the sine go? Does the tangent go in the positive y direction? Yes, also it does. So which means we have all 3 values in the first quadrant or first quarter of the circle are positive. Good. Let's have a look at a different angle. How do we actually calculate this? Well, okay, let's see. Back at it, let's have a look. So again, we have a different angle right here. The question is, how big is this angle? Now the angle stretches from here, when we define the angle or how big the angle is, we always go from 0. So 0 is in line with the positive x-axis. So from this point, here is 0 and we go against the clock. Let's just call it beta. So we have an angle that reaches into the second quarter of the circle, right? So let's see again. Is the sign positive? Does the sign go in the positive direction? Yes, it does. That is actually correct again. So we have plus, plus. Does the cosine go in the positive direction? Well, no, it doesn't anymore because positive x is here, but negative x goes in this direction, which means cosine is actually pointing towards the negative, which means minus there. Tangent. Now the tangent, same principle again. This is very, very simple. It's not difficult. Tangent, we said there is a big line and we just make this longer. Well, we do the same thing again. What about that? There we go. And there's the tangent. Alright, same thing again. Just make the line longer. And is the tangent positive or negative? Well, again, we have a negative tangent. So not again, but we have negative and negative. Good. Third quarter. Can you guys imagine that in your mind? Or I'm just gonna draw like one line here. It doesn't really matter. I'm just gonna put it right here. You know, you can take any angle. It doesn't matter. It just has to be in the third quadrant for this to apply. Good. Let's have a look. So, can you guys imagine that again? So we have the sine is going from the x-axis down. Oh, we're going down. That means negative. Cosine, what happens with the cosine? We're going left, which means also negative. Okay, interesting. And tangent, we make this line longer, longer, longer. Ah, that's going up again. Positive. That's correct, guys. Good job. All right, fourth quarter of the circle. Again, let's just draw any line. Doesn't matter really. Let's just put a let's just put a line with a tight incline there. Yeah, let's see again. So we have sine is going down, right? Because the sine is is connecting the point where the radius intersects the circle with the x-axis. So the sine has to go down again, all right? So again, negative. And we have cosine. Oh, like look at this, guys. Cosine is this length right here, or this length, doesn't matter. And so we have that positive again because it's pointing towards the positive direction. And now we have the tangent again. Okay, we see tangent. We make this line longer, longer, longer. Somewhere down there they intersect. We don't care. Just want to know whether or not it's positive or negative. Negative. And this table right here is very important because you get an overview of which function which function is positive. Sorry about that. Which function is positive or negative in which quarter, which is very important to know because you can just say off the top of your head, okay, this has to be a negative value. Therefore, you know, when you have a fraction and you're dividing by sine or cosine, and you have a negative number on top, and you have a cosine of, I don't know, cosine of 120 degrees, you will know there's a positive number because minus divided by minus will equal to plus. So, yeah. All right, guys. So this is very important to know whether or not the angle that you guys have calculated will be positive or negative. Let's now speak a little bit about the areas of application where this can be useful. Well, or let's first, instead of speaking where this can be useful, let's speak of where we can actually use it, because that's, I think, the most important part, to know when and why you can use it. So this thing as it is, you can only use in right angle triangles. Alright, so remember that. You cannot use these three functions in any triangle. It's not a thing. Oh, shit. I wanted to draw a different angle there. You cannot use it in this triangle, for example, because there's no right angle right here. Yeah, right? So these functions can only be used in right angle triangles. Alright guys, so I was just yapping all the time, but let's actually have a look at something practical. So what we can actually apply. So we have just a sketch here basically, but the way to understand this is you're standing here to this is your point, and you're actually looking, you know, into the distance, and a balloon actually started rising from this point right here. And the balloon was rising steadily with the same speed, and it was rising up and up and up and up. And you're wondering, okay, how high is that balloon right now? How can I measure that? Well, you know that the distance from yourself, your point where you stand, is 2 kilometers to the point where the balloon has or took off, and you have a angle measuring device with which you can basically just point your camera, you could also say, and it's going to tell you what angle there is basically with the 0 degree plane. So yeah, let's have a look at this example. So what are we actually looking for? Well, we have 10 minutes and 15 minutes. Well, how can we calculate this? Of course, we have to use the trigonometric functions. So let's have a look. So the question is, how high is this balloon after 10 minutes? Let's just call this is equal to x, right? So we can say that we have the opposite side, right? Remember, we have sine, cosine, tangent, right? Given our what? The opposite side and the closest side. So what does that mean? We have to use the tangent, right? So we say tangent of 14 degrees is the angle right here, so we just say tangent of 14, and that is equal to what? We said tangent is defined by opposite side divided by closest side, which means x over 2000, right? Because 2 kilometers is just 2000 meters. We can also just write 2, but I like to use SI units, so basically meters, seconds, and so on and so forth. Good. So now just doing simple math, we write times 2000, and we get 2000 times 10 of 14 is equal to x. Good. And this is our first solution for the first question. And to give you guys a little bit of a contrast or of an idea how big these things are, 10, 14, what does that mean? 10, 25, 10, 65, 10 something. The tan, actually this is very important also to know. So we have sine, let me just write this down again. So we have sine, cosine, and tangent, right? The three trigonometric functions. If you remember the circle that I drew before, could sine, cosine, and tangent ever exceed the value of 1? Could those lengths ever, in other words, could those lengths ever be bigger than the radius? And the answer is no, but only for two of them, right? We saw that yesterday. So, and we also said that sine and cosine and tangent can all be negative. So what does that mean? Well, it means that sine and cosine cannot exceed the value of 1, but they can also be negative. What does that mean? Sine of cosine can go from -1 to +1, right? That's basically the values that sine and cosine, so -1 to 1. This is basically just bigger and bigger is equals. So for the tangent, what did we say? The tangent of 90 degrees is undefined. Maybe you guys can remember that because those two lines never intersect. Yeah, right, but like, what if the angle is like huge, like pretty like massive, literally like 89.9999999? Well, that actually might reach to infinity. And this is where the tangent comes in. So we actually have negative infinity to infinity. These are the values that sine, cosine, and tangent can take. But remember guys, tangent of 90, and not only of 90 degrees, but which angle also makes the tangent undefined? That is 207 degrees. So I'm just gonna put down here tan of 90 and tan of 270 are undefined. Okay, keep that in mind, guys. All right, I'm gonna pull up my calculator. Let's plug this in there and let's do it. X is equal to 498.65 meters. Never forget the unit. And the question is, guys, one thing that, of course, I'm interested in at least is the balloon, because I said previously with constant speed, but that might actually not apply. We have to figure that out ourselves, because 10 is just 2/3 of 15, right? Because 3 times 5 is 10, 3 times 5 is 15, 2 times 5 is 10, right? Good. So in theory, we could just say, okay, we take the x length, multiply by 1.5, we should get 15. Let's prove that actually. If that's true or not, I don't know myself. So let's just put y equals 15 minutes. And that's basically the question. Which height is the balloon at after 15 minutes, which is y. Good. So in this part, 10 of 22 this time because it's a bigger angle. It's not that difficult, you know. Y over 2000, right? Just do the same thing. So y is equal to, you guys can do that by your own. I'm not gonna do that anymore because you guys got that. We get 808.05. So what does that tell us? Two things. Number one, tangent of 14 is not times 2 is not the tangent of 22. Right, because if it were, then we would get the double of this in this result. Does that make sense? Because something times 2 is just something that's times 2. And that's pretty dumb anyways. But no, my point being, if this were the case, then we would actually get like, now what, 997 point something, you know? but we don't get that. So this is not true actually, so let me just get that away here. Good. We actually figured out that this height, x, is 498.65 meters, and y is 808.05 meters. Great. Second thing. A little bit of, you could say, physics also for you guys. So the question is, remember this, guys. So I'm just going to put this away because I'm going to leave this here because this is very important, I think. The question is, what is the velocity or the average velocity that the balloon has traveled? And what do we know? We know that the velocity is just, guys, distance over time, right? Because meters per second makes sense, right? And this is basically just a very simple calculation. But remember, guys, I said I like to use SI units, t time in minutes, which means we have the distance traveled was before 498 point something, so let's just put 498 here, and we have 10 minutes, so we put 10 times 60. There we go. 0.83 meters per second is the average velocity of x, and Vy is just the same as Sy over Ty. Let me just put an x there also. So we have, what do we have? 808 over 15 times 60 is equal to 0.897 meters per second. Great. So that's basically very simple. And the third thing that we should calculate, how many percent did the velocity change? And I think that's pretty simple, so let's not do that, but I got a question for you instead. Question is, I want to figure out how far I am away from the balloon. I'm looking at the balloon, but I'm wondering, okay, how far am I away really? Now, some of you guys might say, but Pythagorean, God, I can never spell that. A plus A squared, B squared is C squared. This theorem right here. But let's actually calculate that with sine, cosine, tan, shall we? So, let's remember. We said closest side, opposite side, longest side. So, we can actually put two L's here because these are both the longest sides, right? And let's actually use two different functions for this one. So, we can just say that we have these two values, right? So, and we have also this one. So, we can actually say that this angle has to be 90 minus 14 because it's a triangle, and as I've already written on top here before, it was the sum of all angles is 180 degrees. We have 90, so 180 minus 90, and then minus 90 minus 14, and that is this angle right here, I think, if I'm not mistaken. Good. Anyways, so let's just call this beta. And we have beta is 90 minus 14, which is just the same as 76 degrees. Good. And now let's have a look. So, let's do this with sine, right? Practice for you guys. So, sine of this angle of 14 degrees is what? Opposite side divided by longest side. Remember that. That's very important. Opposite side, which was x, which was 498, divided by the longest side, which is, we don't know that. So let's put it there, as we don't know, right? Good. Now, we just need to do some simple math to figure out times L and divided by the sine of 14, and we get L is equal to 498 divided by side of 14. And now guys, always when doing math, be critical. Think about the things that you actually solved. Is this possible? Why is this? Why is it this? You know, and as we said guys, this is possible because of this exactly. Sine can reach from -1 to 1. It cannot have any other value. So if we divide by a number that is smaller than 1, what does that mean? Well, of course, it gets bigger. So we're dividing by a number that's smaller than 1, so it has to get bigger. And that makes sense because L stands for the longest side. So yeah, let's plug that into the calculator and see what we get. First answer, guys, 2058 meters. You can see it's pretty close to this one, and that has to do with the with this theorem. God, every time it gets me. Anyways, second angle, so that's again 90 minus, so we have this, right? We achieved this, that's good. Let me just put this out here. We have this, let's just call this alpha because we haven't used that yet. Alpha is equal to 90 minus 22, which is just the same as 68 degrees, right? And then we can just say, let's use the cosine in this for this example. Cosine of an angle is the same as closest side, so C divided by L, right? This is just in general, this is just the general definition. Let's now continue. So we say cosine of 22 degrees is just the same as cosine, so closest angle, so we have 2 kilometers, so we have 2000, and yeah, that's basically it. We do the same thing as before. We get L is equal to 2000 over cosine 22. There you go, guys, 2157 meters. So we have now figured out, of course this would have been possible with with this theorem, also with the theorem that I wrote down before, but yeah, I just think it's nice to do it this way also, and to know it this way because it saves a lot of time when you really know how to do it. To sum this all up, guys, sine, cosine, tangent, very important functions in math because they display the relations between angles and sides. That's what they do basically. Good. One thing that I want to also clarify as the last thing today is why can this work in a triangle that is not 1, where the longest side is not 1, right? How does this even work, right? Why does it? Okay, let's have a look. So you guys might remember, should be a right angle triangle right here, that in the unit circle we had a triangle with its longest side is equal to 1, right? That's correct. And so what we are doing when applying this is nothing except for doing this. We're saying make the triangle a lot bigger and just multiply this value by anything. 1 times x, right? So you might have like, I don't know, you might have like 5, or you might have like, let me actually put some concrete numbers here. So let's just put it as 5, right? Let's just put 5 here. And so this is all that we did. We made the triangle bigger, right? And but these values still don't change. You know, you have sine, cosine, and that also shows when you do the calculations. Because how is the sine defined? It's defined as opposite side to longest side, right? And that is the literal definition of this function. So what are we doing when we multiply by the longest side, right? We multiply by the longest side. We basically just have longest side times sine of an angle is the opposite side. And does that work out? Yes, it does, because this side right here is the sine of an angle, which is in case this one, right? So we have it also here, right? And we can also say this angle, although this is not 1, we can also say, okay, this has to be the sine. And what is the factor that we're multiplying this to this? Times 5, right? And where can we see that? There we go. 5 times sine of this angle, would be this side right here, right? So we have 5 times sine of alpha, right? I hope this helps you guys understand what this actually does, why we can use it in any triangle, because we basically just multiply any side by a given factor, and just doing one simple calculation, we get to the fact that you have a multiplication factor. Basically, this is how you guys can remember it. You have a multiplication factor, which is L in this instance, which is just equal to 5. So 5 is equal to L, and then you have L times sine of alpha is just equal to let's put it like this so that it doesn't look like a 0, right? So you have opposite side. Great. So I hope you guys understand this now a little bit better. Summary. Sine, cosine, tangent are all functions that you can use in a right angled triangle. There's also another video that I'm going to be posting about the laws of sine and the laws of cosine, because there is actually exceptions for where you can use these 3 functions in any triangle. I will post that also. Anyways, moving on. Sine ranges from -1 to -1 to +1. Same goes with cosine, from -1 to +1, because if you remember that circle there, the rate is, or the maximum distance traveled from the center to the outer point cannot be greater than 1, right? Because the radius is 1. So there's no way we can actually exceed 1. We know that the tangent is when we draw a tangent here, so this should intersect at only 1 point and be right angular to the x-axis. And then we have, so basically when we say, okay, the angle is extremely, extremely, extremely big, so that they intersect somewhere in infinity, they intersect, you know? That's why we say negative infinity to positive infinity, but keep in mind, tangent of 90 is undefined, and tangent of 270 is undefined as well, because they never meet, at least not in 2-dimensional space. Guys, thank you very much for watching. I hope you guys learned something, and learned this topic because I think it's very important. Not only, you know, you guys might say that the previous example was shit. That's okay. You know, not everything can be great in math, but this is a very important concept that I think everybody has to know, and I hope that I could help you guys understand this a little bit more with my demonstration and my video. So yeah, have a good one, guys. Thank you for watching, and see you in the next one. Goodbye.